Hi guys, today let's talk about rocks. Talking about rocks, I'd like to talk a little bit about what we learned about the difference between rocks and minerals. You may remember that we talked about how this rock, granite, can have quartz and feldspar and mica in it, but it could have all kinds of different percentages of these in each rock. One rock you find, a rock of granite you find on one side of your yard, would be different as far as its makeup as a piece of granite you find on your other side of your yard. Minerals are the building blocks of rocks. So these quartz, feldspar, and mica kind of help make up the granite, and that's true for almost all rocks. Most every rock is indeed made up of minerals. However, some rocks actually do not contain any minerals. One of those is obsidian. Obsidian is a natural glass, and it has no crystal structure. It's just glass. And one that's probably a little more common to us is coal. Coal is actually the remains of ancient plants and animals that have been pressed into a hard rock. Now let's start talking about the three different types of rock. And that's where we'll spend most of our time today. Three different types of rock. We have igneous, sedimentary, and metamorphic. Now, igneous rocks we'll talk about first. They are formed when lava or magma cools. And I have this volcano here. It's lava, this red material that comes out of volcanoes, substance that comes out of volcanoes, is lava once it comes out of the volcano. And whenever it's down here in the earth before it comes out of the volcano, it's called magma. And that stuff has to cool at some point. So it'll be magma down here. The magma could cool before it actually comes up out of the volcano. All this area right along the edge of the volcano could be cold enough to where all this turns into rock. And of course, whenever after the lava flows out of the volcano, it can cool here on the surface. So whether it cools down here, whether it cools up here, you're going to end up having what's called igneous rock. See if I can write that again. Let's write it in green. Just to be writing it in green. There we are. Well, anyway, that's what igneous rock is. Igneous rock is when the lava or the magma cools. That makes igneous rock. Now, sedimentary rock is when pieces of sediment become pressed together. Here you have on the surface, you have sediment, you have materials, and it's more obvious when you get to oceans or lakes. Here we have like a little lake. At the bottom of these oceans and lake, you're going to have sediment that falls down. And as it falls down in a period of time after time after time, it gets pressed downward. And those pressed layers of rock make sedimentary rock. And sedimentary rock is indeed often found where oceans and lakes have been, not necessarily where they are now, but where they also have been. So sedimentary rock, pressed down layers of sediment commonly formed around oceans or lakes. Metamorphic rock, however, is often formed deep underground, such as in this area, where you have a lot of pressure. It's formed under pressure, and it's formed under heat. All this rock here has a lot of pressure that goes with it, and it can actually change the composition of the rock to be metamorphic. Metamorphic is under a lot of pressure and heat. Sometimes you can get like magma here. This layer that's kind of around the magma will get a little bit warmer than layers that are nowhere near the magma. So you could actually have the heat from this magma change some of the rock in the vicinity to metamorphic rock also. Now rocks, these three different kinds of rocks can change, and once an igneous rock, not necessarily always an igneous rock. And same thing with sedimentary and metamorphic. For example, let's take the igneous rock. Let's say the igneous rock is comes from the lava that is formed, and say sediments keep piling on top of it. Eventually it would become sedimentary because sediments would pile on top of it. This sedimentary rock here can continue to be pushed down, and if it gets down into this area down here, it's not going to stay sedimentary rock. The heat and the pressure are going to make it metamorphic rock. Now the metamorphic rock that's already here, let's say this magma ends up spreading out into this area. All this metamorphic rock is going to be scalded, turned into liquid, and then once it cools again, it will be igneous rock. So you have basically what's called a rock cycle. This lava can turn igneous rock, that turns into sedimentary rock, that can turn into metamorphic rock, that can turn into the lava, which will make it igneous rock again. So you have what's called the rock cycle. If I could draw a straight line, I'd have that under there. Now, let's talk about percentages of all on the Earth's surface. I mean, like this area here. The Earth's surface is going to be about 75% sedimentary. Well, enough of that. About 75% sedimentary. But once you get below the Earth's surface, then you're going to get into some igneous and metamorphic. So below this Earth's surface here, you're going to find only 5% sedimentary. Only 5% below the Earth's surface. Whereas at the Earth's surface, it was 75% sedimentary. So you can see we have a huge discrepancy here where the sedimentary rock is. And it's not going to change much. I mean, if this sedimentary rock gets pushed down, it's not going to stay sedimentary rock. It's going to end up metamorphic rock. And all the stuff that ends up on the surface, say you have a whole lot of volcanic eruptions, all this igneous rock eventually will turn into sedimentary rock when the sediments end up falling on top of it. So that's just how it's going to be. It's not going to change. So, I have some questions for you. Now, these questions I'm going to do a little bit differently than I did before. These questions are, in the last couple of videos, I've given you the answer. Here, I want you to get out a sheet of paper and number 1 to 8. And I want you to write down the answers. You'll feel free to go back in the video, watch it over as many times as you want to, dissect exactly where these answers are if you want to. But I'm not going to tell you the answers here on the video. You have to bring them into class. So you do, in fact, have to show me these 1 through 8 with the answers on it when you get to class. First question is, what are the building blocks of most rocks? And if you need to pause to answer that, you're welcome to. But I'll go ahead and go on to the second question. Number 2, name 2 rocks that do not contain minerals. Question number 3, what kind of rock forms under heat or pressure? Number 4, what kind of rock forms when materials become pressed together? Number 5, what kind of rock forms when lava or magma cools? Number 6, true or false? Rocks can change from one kind to another kind of rock. True or false? Number 7, what percentage of the Earth's surface is sedimentary rock? And finally, number 8, what percentage of below the Earth's surface is sedimentary? Well, I hope you've learned a little bit about the 3 kinds of rocks. Bye-bye.